there, we're pretty much just talking about contours that you see on your screen that are taken off spot heights. So pretty much assignment 1. However, we do talk a little bit about design contours leading into some of the class exercises. For those that weren't here last week, I'm sorry I don't have the time to go over the notes again and again and again, but I will briefly, and as part of those that were here last week, briefly mention a couple of things. First of all, there are questions on this first week's notes. I did cover something like inch to a foot calculation, how to get to 1 to 48. And I did talk about metric scales and the fact that we mostly use numbers with a 5, a 2 and a 1 in it. If it ain't got that, then you probably shouldn't be using the scale. Engineering drawing is fairly boring compared with architectural. Architectural, they tend to do squiggly lines with arrows pointing at things, and things look pretty. They employ that right-hand side of right-hand side of the brain. I don't even think I've got a right-hand side of the brain, but that's all very well if you're an architectural draftsman, but an engineer tends to do what Ingrid taught you and have, where possible, line up your text. Where possible, have your arrow coming from the right part of the text. And the notes tend to be uppercase and regimental. And you can normally tell a big difference between an engineering drawing and an architectural drawing. It's been like that since way, way back. And look, at the end of the day, an engineering drawing needs to display facts, whereas an architectural drawing sort of is, is a little bit up in the air. Let's say nothing much more about that. Engineers and architects have never properly got on. An architect will do a building, it'll cantilever out 100 metres with nothing supporting it, and they'll expect that to be the drawing that finishes like. An engineer will come along and say, you can't do that. I don't know what planet you're on, mate, but that building's going to fall down. So an architect will come back and say, oh no, it looks pretty, we need it looking like that. And it'll go on like that until in the end, the architect says, okay, we'll put a post there to hold it up, right? Oh, engineer says they actually need a beam, and it has to be as big as that concrete beam in the middle of the room. Oh, it's going to look ugly. Oh, yeah, well, you want it to look ugly or a whole lot of people to die? Oh, okay, we'll have to have a beam. So these sort of conversations, and then the architect will go back to the office and go, oh, I hate those engineers. They're always ruining my drawings, I've worked with architects for many years, and they always think they're the ones in control of the job. And you never see a building and someone will say, oh wow, I wonder who the engineer was on that. They always have the architect's name in front of it, And I've seen a few pretty cool buildings around the world. The corkscrew one in Dubai comes to mind. That just blows you away. But everyone says, oh, who's the architect who sort of that? I think to myself, who's the blooming engineer that was able to figure out how to keep that up, you'll find that engineering scales will always be very regimental. The text will be regimental. Engineering symbols on civil drawings will be regimental, and that's how I mark. I look at a drawing and I go, well, I told them to do that. They didn't do it. That's half a mark off or whatever, right? Whereas, and you're sitting there going, oh, that's not fair. That's not much at all. What a mean marker, right? But I know in the real world, my boss would have got out the red pen, the dreaded blooded pen, and put blood all over the drawings, and that blood meant you were staying back till 6 o'clock at night to finish it off. So if you don't learn now, you'll learn when you have to do it in industry. So I talked briefly about symbols, and I told everybody that things like the house was actually a building. You'll see lower down on your drawing, it says existing building. I'd like you to draw that kind of on the drawing, roughly where it is. You can go and have a look, do a rough measurement, or you can take it off Google Maps, there's a building on there, and just do an approximation of how far off the path it is. As long as you show it with some hatching, okay? There's also a building up the top, the Concentrix building, funny name, used to be the IBM building before that. It's some sort of business up there that owns the building. And I talked about the hatch required for the swamp, etc., etc. When you do the tree, make sure you do the exact circle of the tree. So you're going to have to do at least one tree symbol. So start by drawing a circle, putting it on top. It won't fit perfectly, but as close as you can. And then from that circle, make up whatever nice simple symbol you want. You can get these symbols off the internet. They're not that big, and they do look quite rather cool on your drawing. No problem at all if you put them in there. But what I do have a problem is if you put it in massively, it has to be the exact circle size. Don't forget your north point. I don't care how fancy your north point is, it needs to be scaled to the right size, a size that looks okay. Shouldn't be take up the whole drawing, but it shouldn't be massive either. The only line with any thickness are boundaries on your existing site plan. When we come to the proposed site plan, the actual pad or slab or platform will be solid. How solid? Just right click on the, under layers, just make it one thickness more than normal. You won't see it. I just want to acknowledge that it's a platform. Here's the bit that students that weren't here last week are going to struggle with. These are your main text sizes. The main one for writing on the drawing will be 3.5. Headings, i.e. legend, survey data, whatever, down that in the box. 5. Don't worry about the 7. The main title was 6.8, leave it at that. The A1, it's all A1, but the main writing, like I said, was 3.5, which also means the arrows are 3.5. It also means the dimension heights of your dimensions are 3.5, and it also means the settings for the offset are 1.2, which is about a third, and 1.2 for the lines, 1.2 for the other one under the lines, the other setting. 2.5 is only reserved for contour labels and contour spotlights. Now when I say 2.5, 3.5 and 5, you need to do this mathematical sum here to work out what that's going to be in model space. A lot of newbies in week 2 don't do that, and their text is massive. And that's kind of like the first step towards not passing the course. Topographical features were discussed, existing site plan, and the locality plan I went into in quite some detail. There are some examples that I've also uploaded of probably B or C students' work, and I went through some of them and showed how you could actually improve on that. So don't do a direct copy. And that's kind of where you should be at the end of last week after homework. Now I know a lot of you have done some work on it, which is great, but I know some of you are quite a bit behind. This is a 90 hours self-directed study. So 90 divided by 13 weeks. I think most of you owe me about 3 or 4 hours already. Okay. So when it gets to hand in time and you go, oh, I spent 12 hours last weekend. Well, you know, I would say to that, well, you still owe me another 4. Okay. The only way to pass this course really is to put in a little bit of a consistent effort each week. Now to me, I enjoyed AutoCAD, so every time I got a maths question or physics or structures, oh, blow that, I'll go back and do some CAD, right? But to some of you, it's like, ugh, and you avoid it like the plague. There's bound to be something worse than CAD come out. If there isn't, I can organise some structural homework for you, just to push you towards the CAD. No. The other thing is that there are degree students that, you know, it's a little bit like if your family's got slaves back home doing all the work. Well, that's not for me. I'm not going to be a draftsman, you know. But the true reality of our degree, and I've got a degree here at UniTech as well, so the true reality is that you're going to be a little bit better than the diplomas, more of an advanced technician. They're going to utilise you to do calculations because you're slightly better at the maths. But the reality is a lot of the work's going to be doing drawings, whether you're using the modelling programs and CAD or whether you're just doing CAD. So it's pretty hard to avoid it, and the real reason for that is they don't teach these things at Auckland Uni. So you guys are in the primo seat to get the jobs because they don't kind of go, oh, we've just won a job, the Northern Motorway, what are we going to do? Let's hire 3 greenies from Auckland University who can't do a damn thing except for calculations and put them on AutoCAD and Civil 3D and, oh, they're not pumping out any work, right? Because they haven't been taught the program, so it's a bit of a dumb employment. Whereas they can bring in a UniTech student and go, have you done AutoCAD? Yes. Oh, here's some drawings. Can you please get on with doing those? Yeah, no problem. And away they go. So the reality is if you're in a consultancy, you will not be able to avoid CAD. So the more practice you get, the better you'll be and the easier it'll be to merge in with everybody else. Okay, if you go to construction, you'll be sitting in a little side office. You've seen them all with their orange reflecto vests running around the place, giving people orders. Half of your work will be outside doing that. But guess what? If you're going in, you get an email, guess what it'll be? CAD drawing. You'll have to open it, you'll have to look at it, you'll have to see what's on site, you'll have to draw a wee picture on top of it of what's actually on site and send it back to the consultancies to get it revised. So, unfortunately, if CAD is becoming your weak subject, it's very important to get a bit stronger in it and employ it. Okay, so as far as contours go, are you now doing surveying out there with Dave and his team? Yep, you all started to do the old hole in the ground and taking a shot at it. How many times around the block did you go with your levelling? Have you done that yet? 3 times? 2? 4? That's not bad actually. It sounds like doesn't sound too good, but it's actually not bad. I think the record's 9. I don't think that student's here anymore. You have to go round and end up finishing on the same point. And you've got to be within 3 or 4 mils, so you have to do it again. You go right round building 112 to 115. You go around there. Normally, I don't know, he may have changed the routes. And he checks each other point when you get to it. Well, those spot heights are also reflective in our assignment. But what a surveyor has to think of and what an engineer has to think of is, because as engineers, you're sending the surveyors out to do work for you. They're your eyes and their ears, but they're also got to bring back every bit of data that you need. It's okay if your site office here at UniTech and you're doing the grass out there. It's not okay if your site office is in Drury and the job is in Whangarei and the budget is for one night up there and 1 day surveying. Because they come back and you take one look and go, oh, you've missed that. See you later. The next day, right? So that's a whole day out of your budget, which could be 2 surveyors or 8 hours. So suddenly your budget loses $5,000. And whose fault is it? Is it your fault for not telling them to do that, or is it their fault for not having the nous to figure out what they should have picked up. So we bit of both, really. So we try and teach our surveyors here, we have a national diploma in surveying, what to think laterally on what the job's going to be, and we try and teach them some of the things that you engineers do. Pipe work, construction, buildings. We also start getting into things where there could be problems. There could be something to do with the local iwi that you can't go anywhere near. You know, and if the survey doesn't pick that up, they go ahead and design their building right over the top of it. Sounds funny, but by crikey, it's not funny for the people that are doing the job. It could be a number of things. Geotechnical issues, where the land looks like it's going to slip away down the valley. If the survey doesn't pick up a slide, a geotechnical situation, then they'll have to go back and pick it up again. Look, I was surveying down in the South Island, and I was just the lad. I was part of a team. I was the chainman, young 20-year-old, and I went out the back of the four-wheel drive, and we were surveying a slip on the side of the road, and I set the equipment up, got it all ready for the rock star to come out and work it. I got back in the car, we heard a bit of a funny noise, and I went to get back out, and literally the car was on the edge of a slip, whole bank falling away. And the guy says, "Oh, where's the equipment?" I could hear him at the back. I said, "Well, it was just set up there on the side of the car." He said, "No, it's not. It's gone with the slip." So that's a good example. If I had been experienced in surveying, I might have gone, well, hold on, maybe it's not a good idea to set up a survey equipment on top of an existing slip, which could go at any time. So only one small example. So a surveyor or an engineer needs to think about the job they're doing, and they need to figure out what sort of size contours they're going to do on their job. So for example, if you were doing a bowling green, that's a very good example, because with a bowling, it has to be very, very flat and level, right? Outdoor bowling. But what if it rains? You don't want to create a swimming pool situation, so there must be a small amount of drainage in the corners towards the drains, right? So if you get a small downpour, it just all clears, they can come out again and start playing after giving it a bit of a sweep, right? A courtyard out there between the hub and building 114, it's quite flat, it's all been cobbled, looks nice, the seating on it. I have seen an absolute downpour there where there's been about that much water sitting. So whoever did it didn't design it particularly well, but if they used 0.05 or 5 mil contours, they may have been able to figure out where the problems were with the drainage. Bit of a shame they didn't do it at Ericsson Stadium, but I went to watch Elton John. The water was this deep, and I was wading through it to get my beers, then I waded through it to get my pie, then I waded through it to pay. Ridiculous. It just didn't drain at all. It was like a swimming pool that night. It was absolutely mental. There was two Chinese jokers selling coffees in a caravan. The power was still on, and the caravan was floating away, and they were still asking people if they wanted to buy coffees. It was really crazy, yeah. And then after, we were all sitting there with our drinks waiting for Elton John to come out, and they announced that we had to go now, and the cops started pushing us all out of the stadium. So it was and I got back to my car. I had to wade through water about this deep to get to my car. Some people's cars were completely buried. So that's, I don't know, you can't really blame the road designs there, but at the end of the day, it was a very, very bad evening. There were cars floating down the motorway that night, all sorts of things crazy going on. But I couldn't help but think, had someone taken a bit more time to do some design towards the drains and not away from the drains, how it could have been improved. So when we do the likes of a road, we tend to only do contours accurate to 0.22. And then when we do a schematic, and a lot of you don't know what a schematic is, that's when you look on the news and they might show, you know, that there's been a new road built, say, in the Guangzhou area of China, and it's going to go for 50 kilometres. So they're not obviously going to draw it 50 kilometres long, so it'll be a small scale, but they're not going to do 0.2 contours either. They'll only do sort of like 10 metre or 20 metre, so you can see the banks. But you know, if you did contours like that, it'd be crazy, wouldn't it? You know. I said China because it's a vast country, it's huge, and that you know, could be the same if you were doing something in northern India, and it was a long distance, and they're trying to show a scheme of what they're doing on the news. That sort of thing is a rough estimate of costs, and they would only put contours about every 10 or 20 metres on something like that. So you have your different variances of contours. Who decides it? Well, I'm sorry, but it's you guys that decide it. You're the engineers. You know what the final product needs to be. So that message needs to be relayed to the survey. Okay? And if they argue about it, then you say, well, okay, if you don't do that, you don't get paid. All right? And we had to write some quite big briefs as engineers for the surveyor before they went out on site, because we knew that they would do exactly what you said, but if you didn't put it on the paper, they'd shoot out there and do it again. Now you'll see your assignment has got contours intervals. You've been told what intervals you need, and you've also been told what intervals you need on your design contours as well. Now contours have got various characteristics, and there is a question on those characteristics in the test. I guess the main thing to think about is if you're looking in a plan view and you see an even gap between the contours, there's a very good chance that that contour has been done it's something that's been done by humans, because it's even, so it'll be an even slope either up the hill or down the hill, which means probably it's been done by humans. You don't get that evenness in natural ground as much. The other thing is contours will always close somewhere. If you take Mount Eden and you did contours going up there, it would be like circles going up in the air. And then if you look down the crater of the volcano, there'll be more circles going down the crater. That's actually a good example of don't jump to conclusions when you see a lot of contours going around in a circle or close to a circle. Don't think, oh, that's a mountain. It might be a depression. So have a quick close look at what the labels say before you make a decision on anything. A good example of telling a surveyor what to do is you might say to them, take cross sections, pick up cross sections every 20 metres, but you say, I notice there's a big depression over there, big hole, and it may fall between the 20 metres, so please take an extra shot where the hole is, so we can get accuracy for our volumes. So really the engineers are running the show. The surveyors will pretend that you're not, but if you don't actually ask them for everything, they won't actually pick it up. When I say all contours close on each other, on themselves, it doesn't necessarily mean they do it in the drawing. The drawing might be zoomed in on an area, like we are, and the contour might go way over here and outside of the drawing join onto itself. So how do we estimate contours? what are the methods, and how do we do it more accurately? Well, in the first one there, I've got 51.5 and 50.6. Maybe I should stand up and take a wee walk along there and get some reading done.
Could I access that?
Got a bit of water.
I don't think we have to record this. Delete this video.